On page 7, we are going to try to write down the exact values of the 6 trigonometric functions of the angles pi over 3, which is 60 degrees, 2 pi over 3, which is 120 degrees, 4 pi over 3, which is 240 degrees, and finally 5 pi over 3, which is 300 degrees. We did a similar kind of thing on page 5 for the angles related to pi over 6. When we did that, we used the unit circle. So we went to the unit circle that we had drawn for those angles with the right triangles, and we read off the sides of the right triangles because we know that, for example, sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and so on. Okay, you can do that here for sure. So like if I pick a random angle, let's say I look at 2 pi over 3 or 120 degrees, you would go to the unit circle that we drew on page 6, okay? Here is 2 pi over 3 or 120 degrees, okay? When we were finding the coordinates, the xy pair, this point, the coordinates of this point on the unit circle, we constructed this red right triangle in order to come up with those coordinates, okay? So if you remember how we got it, if you're looking at 120 degrees, if you drew that, you would start on the positive x-axis and then rotate counterclockwise through 120 degrees. And so once we got there, we drew a line from the center of the circle to this point on the circle. And then from there, we constructed our right triangle. Okay, so if we went 60 extra degrees from the 120, that would bring us down to the halfway mark, so 180 degrees. So we said this was a 60-degree angle, okay? And we learned on page 5 that when you're calculating trig functions using these right triangles, you have to use a reference angle, okay? So to do this with the triangle, you wouldn't use 120 degrees. You would draw to the nearest spot on the x-axis, okay, and use that angle. So you would use, to calculate here the trig functions, you would use this 60-degree reference angle, okay? And then from that, like if you're looking for the sine, you would do the opposite side over the hypotenuse, okay? So here from this angle, you would go across and find your opposite side. Your opposite side has length square root of 3 over 2. Okay, you've got to remember when you're calculating these 6 trigonometric functions that you do have to take the quadrant into account so that you get your signs correct. So if this angle is in the second quadrant, and so the y value there should be positive. Okay, so you would the opposite side, we are considering it to be positive square root of 3 over 2, and then you would divide by the length of the hypotenuse, which is 1. So if you go back over here, we would write down that the sine of 2 pi over 3 which is the same as the sine of 120 degrees. It's going to be the square root of 3 over 2 over 1. And so it's just the square root of 3 over 2. Okay. And then you could do the same thing for the cosine. Cosine is going to be the adjacent over the hypotenuse. So if you went back to that triangle, okay, you're still using your 60-degree reference angle, but you would use the adjacent side. Okay, so the adjacent side is right here, this thing highlighted in yellow, this distance. We know that that side has a length of 1/2, but since we're in the second quadrant, these are negative x values, so you need to consider that side to be negative 1/2. Okay, so that's kind of like the length of the adjacent negative 1/2 over the length of the hypotenuse, which is 1. Okay, so you would calculate here that the cosine would be, see if we write this out, the cosine of 2 pi over 3, which is the cosine of 120 degrees, would be negative 1/2 over 1, okay, which is negative 1/2, okay? So you could use the triangles, okay? And once you have sine and cosine, you can get the tangent, the cosecant, the secant, and the cotangent, okay? But you don't have to spend your time reading off the triangles. We learned something huge by the time we got through page 5. And you can see that if you don't remember, you can see it again here. Okay, if you go back and you look at the angle on the unit circle, If you go back to 2 pi over 3 or 120 degrees and you look at the coordinates of that point on the unit circle, you see these two numbers. Okay, when you go back over here, you realize that negative 1/2, this is the cosine of 2 pi over 3. Okay, look at your chart. Okay, the cosine is negative 1/2, and the sine is the positive square root of 3 over 2. That is the y coordinate. Okay, so this is the sine of 2 pi over 3. Okay, so this was the big takeaway when we did this for page 5. And that's the way you should start thinking about this, okay? If you are looking at a particular angle on the unit circle, if you look at the coordinates on the unit circle related to that point, the x-coordinate is the cosine of that angle, and the sine is the y-coordinate of that xy pair, okay? So x is cosine, y is sine, okay? So that makes doing this a whole lot easier, okay? So if you go back to page 7, okay, if we wanted to look at pi over 3 or 60 degrees, all we have to do is go to the unit circle, look at that angle, okay? Here's 60 degrees, or pi over 3. Here are the coordinates related to that point, okay? So this, the x-coordinate is going to be the cosine and of pi over 3, and then here's going to be the sine of pi over 3. That's all you have to do, okay? So we can go ahead and write that in, okay? The sine of pi over 3 is going to be the square root of 3 over 2, okay? And then if you go back, the cosine is going to be positive 1/2, okay? That's it, okay? You can even put that here. I'll put cosine is the x-coordinate, sine is the y-coordinate, okay? All right, and then we can do it for 4 pi over 3. Okay, if you go to 4 pi over 3 on the circle, okay, here's the angle 4 pi over 3. Here are the coordinates associated with it, okay? This is the cosine, this is the sine, okay? So I'm going to go back and just write that in my chart, okay? The cosine is going to be negative 1/2, okay? So negative 1/2, and then the sine is going to be negative square root of 3 over 2. Okay, that's it. Okay, and then lastly, if I look at 5 pi over 3, just go read off the unit circle. Okay, so go find 5 pi over 3 or 300 degrees on the unit circle. Here's the point. Here are the coordinates. Okay, the x-coordinate is going to be your cosine. Okay, so the cosine of this angle is going to be positive 1/2. And then the sine is going to be the y-coordinate, which is negative 3 square root of 3 over 2. Okay, and that is it. That's all you have to do. You don't have to use the right triangles unless you really want to. Okay, once you know sine and cosine, okay, then you can figure out the 4 remaining trigonometric functions. Okay, why? Because we know that tangent is sine over cosine. Okay, and so if you translated that into the coordinates, okay, that's going to be the sine is the y coordinate over the cosine, which is the x coordinate. Okay, so then you could do that calculation here. Okay, if you then went and did the cosecant, okay, cosecant is 1 over the sine. Okay, so again, if you use this, thought of this in terms of the coordinates, the sine is the y coordinate. Okay, so all you have to do here is 1 over the y coordinate. Okay, and then secant, it's 1 over cosine. Okay, so we know that the cosine is the x coordinate. Okay, so to get the secant, you just have to do 1 over the x coordinate. And then lastly, we know that cotangent is 1 over the tangent. Okay, if we go back to tangent, we know tangent is y over x. Okay, so we just need to flip it. Okay, so flip the tangent. So this would be x over y. Okay, so that's all what you have. That's all you have to do here. Okay, you could also just use the numbers. Okay, I will finish this column off for 2 pi over 3 or 120 degrees. Okay, and then I'll stop the video. But in the filled in notes, I will post the completed chart. Okay. All right, so we did the sine and cosine for 2 pi over 3 or 120 degrees. So now if we want the tangent, we just need to do the sine over the cosine, okay, which is, again, the y coordinate over the x coordinate if you look on the unit circle. Okay, so here the sine is going to be the positive square root of 3 over 2. We're going to divide by the cosine, which is -1/2. Okay, this is going to be square root of 3 over 2, change to multiplication, flip the other fraction. Okay, and so we will end up with the 2's will cancel, and we will get the negative square root of 3. Okay, so there is your tangent. All right, continuing on. Okay, so if we want the cosecant now, we just have to do 1 over the sine. Okay, we know the sine value is the square root of 3 over 2. So all we need to do 1 over it, we just flip it. Okay, so instead of square root of 3 over 2, it's going to become 2 over the square root of 3. Okay, and then rationalize the denominator. Okay, so we're going to end up with 2 square root of 3 over 3. Okay, all right, secant is 1 over cosine. Okay, if you want 1 over cosine, okay, you come up here to the cosine. 1 over the cosine is just going to flip it. Okay, so really it's going to be 1 over -1/2. Okay, 1 over a fraction flips it. So this is going to become -2 over 1, which is -2, and you're done. Okay, and then the last thing here is to compute the cotangent. And all we have to do, we know that the cotangent is just the tangent flipped. Okay, so go to your tangent and flip it. Okay, so the tangent is the negative square root of 3 over 1. So if you flip that, that's going to be 1 over negative square root of 3. Rationalize the denominator. You're going to end up with negative square root of 3 over 3. Okay, and there are your 6 trigonometric functions for 2 pi over 3 or 120 degrees. Okay, and like I said, I won't continue doing this in the video, but in the filled in notes, I will post these answers. Okay. By the way, the same thing is going to happen when you get to page 9. You're going to see a similar type of chart. You're going to see it for the angles related to pi over 4 or 45 degrees, 3 pi over 4 or 135 degrees, 5 pi over 4 or 225 degrees, and then finally 7 pi over 4 or 315 degrees. Okay, I am not going to do this over video. I will put this in the filled out lecture notes when I post on D2L. This will be a good exercise for you, okay, to fill in this chart. Okay, so remember, you have options. You can go to the unit circle that we built on page 8, okay, related to these particular angles, and you can use the right triangles to compute those trigonometric functions. Or you can use the fact that, like, you know, if you're at the angle pi over 4, okay, you look at its coordinates, okay, and you know that the x coordinate is the cosine of pi over 4, and you know that the y coordinate is the sine of pi over 4. Okay, so it's up to you how you want to look at it, because both representations are correct. Okay, so you can look through the, you know, if you want to try this for the pi over 4 angles, you're welcome to do that. That would be a great exercise for you. And then you can go into the filled out lecture notes and you can kind of check to make sure you're doing this correct.